Hello everybody, this is the National Qualifier Briefing. This is a departure from what we would normally do, but due to the COVID-19 situation we're going to have to hold our qualifiers as an IT-based solution rather than the normal method. We'll go into it in a little bit more detail. So, for WorldSkills UK Live, to qualify you're going to need to complete some online tasks and upload them by the 21st of September. So the normal way we would do things is each team would be visited and assessed on a prototype of their main project and portfolio A, B and the costings. Unfortunately, due to college and business closures, we just can't do that this year. So we've done a few things to give you more of a chance working from home to actually get through. So the qualifier has been designed to take elements from the national brief that can be demonstrated through IT-based systems, so CAD, a few spreadsheets, maybe some portfolio building on Word or Google Docs, that kind of thing. I've opened a Google Classroom for you to upload all the information. We'll have a look at how that works for those of you who have not used it before. And the qualifier date has been moved from the end of June to September 21st. This is so that hopefully we will have colleges and businesses back open and you will be able to have access to a mentor or some help later on for the bits you can't do. But I would strongly suggest that you find a way of communicating amongst your teams, something like Google Hangouts or through Messenger or Snapchat or anything else that you want to use, and that you complete as much of this work as you can long before that deadline. Obviously if you're not working or you're not in college over the summer, that's a perfect opportunity. And I've also created some support videos that we'll have a look at in a moment. I'm going to be available on Google Hangouts to be able to have a chat with any of you who've got questions. I will schedule a question and answer session with each of you, and of course I'm always available by email. So for any information on the qualifier, the national finals, or any other information relating to the MTC, my email's there. It's dayton.unit@cambria.ac.uk. Those of you who wish to have a face-to-face chat via Google Hangout, please email me and we will arrange that. I'm going to try and arrange a question and answer session regarding both the qualifier and national for each of you anyway. Your mentors are more than welcome to join in on that as well. And the Google Classroom code for qualifier information and indeed the national information is JDJNZUJ. So the first thing you need to do, for those who've not used Google Classroom before, is simply type Google Classroom into your browser. Now you can log on to Google Classroom with your college or work email address. That doesn't always work for everybody. Does for the vast majority, but not for all. So if you're having problems, please create a Gmail account. It's free, and use the Gmail account in order to access it. To be honest, if you're going to be working remotely in teams, it's a good idea if you all have a Gmail account, or if you don't have a similar college account or work account that will allow you to use a shared hard drive to pass information backwards and forwards between you. Be very, very useful. So at the top of the screen when you get into the Google Classroom, just under the taskbar there should be a plus, and if you click on that plus you will be able to select join. When you select join you need to enter the classroom code JDJNZUJ, and it should take you to this classroom, which I'm just going to show and have a look through. Okay, so when you get into the Google Classroom, it should be entitled WorldSkills UK Live MTC Qualifier Information and Upload Portal. You'll be on a stream like this and it will show that I've posted several items. That's not really where the information is. You need to click on Classwork. And on Classwork, if I go to the bottom, what you will find is you have the national brief. So you can open up that category, and what you can see is this brief is to be used for the November final. You'll need to design to this brief for the qualifier. So that's the reason that information is there for you. You should be able to click on and download this information, and that is the full national final brief. Similarly, the qualifier brief, which is a stripped down IT based version of this, is accessible here. And I've asked that you can upload the information to here, but if you are having real difficulties, then you can always email it through to me. It is far more secure and far easier for both sides if you upload on the Classroom. Okay, so there are a couple of YouTube video links here. Firstly, there's the briefing for the national final. So if I click on that, you could just click on the YouTube line and watch it. There's also a video here on how to create Portfolio B and the standards required for the drawings. There will be some more videos, including this one, put into this by the time you get to it. Okay, so competition readiness, there's no documents in that at the moment, but what it will have is lots of paper-based documents that will guide you through how to compete, the kind of things that we're looking for. There's a bit again on the drawing standards and all that kind of information. So then we've got the teams that are registered so far. There may be more teams and I will add them, so Magellan, Rico, GE Aviation, Merthyr, Tydfil College, Kronospan, Decker, and this one I've actually populated. You'll all be populated the same. So this team, the TLQ team, if we view more here, we can go right to the very bottom, and you'll find that we have an assignment upload section for 5.1 toolbox weight. Now your view will be slightly different to mine, because my view is based on the fact that I'm the teacher of the classroom, so I can see things. So when I click on view assignment, it will tell me who's turned it in and how many it's been assigned to, and up in this section will actually pop up all the work that you submit. But for you, it will be a section up in the top right hand corner here where it says upload and hand in, and that's how you do it. You finish your document, so you might have a spreadsheet here for toolbox weight, then you store that somewhere on your computer or on a Google Drive, doesn't matter which. Go up to here, find it on the link and select hand in. So what you will have is toolbox, weight, ergonomic hand controls, manual propulsion system, stopping distance, speed test, system interface, flashing lights, onboard charging system, battery system, distance covered, packed volume. Section 6 is costings, 7.1 is the video, and 7.2 is the costing spreadsheet, operation and maintenance manual for 7.3, 7.4 sales brochure, 7.5. I'd ask you that you could actually put and Portfolio B, which is your 2D and 3D drawings. Now I need to ask you that you make sure you put the right information in the right place. If you put it in the wrong place, there is a good chance I'll find it, but the chances are you may lose marks because I haven't found it. So please put the right information asked for in the right section. Now up here, when you come to Portfolio B, 2D to 3D drawings and schematics, please only upload these as PDFs. If you use Inventor 2019, I can guarantee I won't be able to open and view your files, so you won't get any marks for those files. So simply on Inventor, and just to demonstrate that, if I have a drawing such as this one, I can go File, and eventually it will come up, Export to PDF. And as soon as you export to PDF, it will give me that file as a PDF, or give you that file as a PDF, and allow you to upload it to the classroom nice and simply, and guarantee that I can view it. Now, on the 21st of September, when you hand in, I will only have a few days to mark everybody's work and get it to WorldSkills UK in order to make sure that we have time to book hotels, get the list out, get the invites out, and everything else that's got to be done in order for you to compete in November. So if you make the mistake of not putting the PDFs in there, there's a chance I will not get a chance to ask you for them. So please try and make sure that you've got the right information in the right places and this section done as PDFs. So once you're in the classroom, as we've just demonstrated, there are several categories. National Brief contains the brief for the November finals, Qualifier Brief for that, YouTube video links, with some videos to help you and guide you through. Competition readiness, so supporting documents. There's a nice little document about competing and the kind of things we're looking for, and your team evidence upload. So whatever your team name is, please don't upload it to somebody else's, and if you can, make sure your team name is on every single document. Okay, so the qualifier brief. The brief concentrates just on some elements, so obviously I've had to adapt things and change things to suit the current situation. So it's only elements of the full national brief and elements that can be completed using remote working and IT only. You're asked to complete each of the criteria and upload the evidence for this to the Google Classroom, as we've just gone through. Please ensure the correct work is in the correct upload section, and so you can avoid me being confused when marking. So it will mean that some things are uploaded to several places instead of just one, but that's fine. Upload your work at any time. Now, if you upload your work and you decide you want to make changes with it, you can actually unhand it in, change it and hand it back in again. So it'll be marked on or after the 22nd of September, and uploaded work can be taken back down and amended if needed any time up till midnight on the 21st of September. The qualifier brief asks for only some elements of the main brief and elements you need to do to design the product anyway, so they're not things that I'm asking you to do extra. If you were going through the design process for a prototype, most of these things would have to be done. So for example, you will have to be able to make the vehicle go 12 kilometers per hour. So how would you do that? Well, you would calculate using wheel diameter, gear ratios, rated motor speeds, probably a factor of safety, and if you do use a factor of safety, please put that in, to say, okay, right, this vehicle is capable of a top speed of 17 miles per hour, that's way above the 12, we're fine. Okay, so it's things like that that you're going to be asked to do. So the first category that we have is toolbox weight. So when you've done your design, you'll know that you need a 10mm spanner or a 20mm socket. You'll know that you'll need screwdrivers. You'll know what it is you need exactly to put that design together. So what I'm asking you to do is to guess at, to a certain degree, but calculate to the best of your ability, the toolbox weight. So you will need to list all of the tools, so the name or tool of equipment, in a spreadsheet format. You will need to either calculate or refer to manufacturers or sales websites to get the weight of each item, or a similar item if you can't find the exact one. You'll need to list the number of items. For example, you might need 2 10mm spanners, one for either end, and the total weight. Once you've got the total weight for each of your lines, I need a total weight also adding at the very, very bottom to see how heavy your toolbox total is going to be. So 5.5, notice we're missing out 5.2, 5.3 and 5.4 because they're unable to be done remotely. These are things that we are going to have to do at the final, but we can't do for the qualifier. So we're going to look at the weight of your vehicle. So after you've completed a design for your personal transport system, you need to use the 3D models created to calculate the weight of each piece of material or assembly. Then create a spreadsheet similarly to 5.1, only this time it's item number, item description, so it might be item number according to your CAD drawings 001. Item description could be cross member, and the weight in kilograms, the number of items, so you might have 5 of the same piece, you might have 23, you might only have 1, we don't know. So, and then the total weight of that. And similarly, once you've done the total weight for each part, could you please, at the very, very bottom, total that up for me. So, I'd also like you to take 5 screenshots for the items calculating the weight according to Inventor to prove you can do it. And I'm just going to depart from the PowerPoint again and just show you how to do that for those who don't know. Okay, so I'm in Inventor now, and I have a simple 3D model, a piece of box section with 2 drilled holes in it. And what I'm going to do is I'm going to right click up on the top right hand corner, and I'm going to go to I Properties. So the master on the box, right click, and I will get this up. Okay. At the end is the category physical, and physical will at the moment just say generic material. It won't tell me what the material actually is. I've got to tell it. Now, you may be making it out of steel, aluminium, it could be a plastic part, whatever it is. So on this drop down menu, let's say it's polycarbonate, then we go to polycarbonate. This is actually made of steel, and to be honest, it doesn't matter which steel you select. Inventor has a default density for that, and it will work it out to that default density. So I'm actually going to go for mild steel, and it tells me the density is 7.85 grams per cubic centimetre, which is about 7,850 kilograms per cubic metre, same thing. The requested accuracy, high, medium or low, doesn't actually matter, it makes very little difference. So here it tells me that the mass is 274 grams. So I can put into my spreadsheet 274 grams for that item, then the number of items and multiply it obviously, but a screenshot of that and clearly showing the part name or part number at the bottom would be absolutely brilliant. That's the best way to demonstrate that you've done it via CAD. So those screenshots then can be uploaded onto the Google Classroom. So what I would like to see is a spreadsheet of this format showing all the weights, and 5 screenshots that you can put onto Word or Google Docs or something similar. You might even be able to tag them into the spreadsheet if you wish, clearly showing what I've just demonstrated regarding the weight that Inventor is calculating. Of course, I also need the total weight for all of the manufactured parts. Now, I realise that you are not going to be able to do every single nut and bolt, you're not going to be able to calculate the electronic components weight, etc. So we're only looking for the total weight of the raw metals and materials and parts you've designed at this point. When we get to the national final, of course, the entire system will be weighed. So that will be slightly different, and your weight will increase obviously from this calculation. But just to give us an idea of who's designing what and how well it's designed in terms of weight, this is the way we're going to do it for the qualifier. So ergonomic hand controls. You will need to design your hand controls on CAD again, and I'd like you to see 6 view screenshots of your hand control design. So it could be on an angle, it could be the flat elevation, so 6 sides. Can you annotate and give me a description of what it's showing? So I'm showing the left hand side, I'm showing the right hand side. This is where the dead man switch goes, but you must show me the dead man switch and the method of speed control. Now you can do that through drawings and annotation, and also I'd like to see the size of the handle to prove it fits in one hand. It's okay seeing a drawing, but it's not relative to anything. It might be too small for my hand, it might be way too big for my hand, you might have made it 35 meters long, but I need to know that. I need to know it's reasonable to fit. 5.8, we have a manual propulsion system. Now, as discussed in the briefing video for the full national final, any manual propulsion system is fine, but it must fit either on the vehicle or be part of the vehicle, or it must fit in the rucksack with the vehicle. So I need a design for that manual propulsion system, or I need to see a part assembly for that manual propulsion system, and I need you to annotate, write out exactly how that works. So for example, it may be a ratchet where you pull a front handle on a scooter and the ratchet moves the front wheel, in which case I need you to describe what the ratio of gearing is, how far it will travel on one pull, and all the other details pertinent to that system, as well as some very, very clear drawings to show how it works. Stopping in a safe distance. So for this criteria, I need you to show me how the braking system works with a set of CAD drawings similar to the previous one. And again, these need to be annotated to describe. So for example, you may have a brake caliper from a push bike on a wheel. So I would need to see the wheel, the caliper, the brake disc, and the mechanism of actually activating the brake pads. So that could be a hydraulic system off a push bike, it could be cable fed off a push bike, you may have a completely different system and you may be using electronic braking on the motors. Whatever it is you do, I need you to be very specific and tell me what it is and how it works, and show me the drawings for the entire braking system from one end to the other, how it's controlled, etc. Speed test then. Clearly we can't do a speed test, you won't have a physical item and I won't be with you. Normal qualifier, we'd have had a bit of fun running this up and down at a distance to see how fast you could go. So what I'm going to have to resort to for this time is you will know the rated motor speed for your motor that you're using, or motors that you're using to power the item. You will know the gear ratios, if there are any. You will know the pulley ratios, if there are any. Any kind of gearing used, you will know those ratios, and you will know the wheel diameter you're using. So I need you to use that to calculate how far a wheel will turn in one rotation, and then multiply that by the revs per minute, and of course work from that and get the kilometers per hour. So you need to show all the workings for the calculation, and you need to clearly show that the speed is at least 12 kilometers an hour. If, and I will check some of the calculations randomly, if the calculation is wrong, you won't get the mark. If the calculation is below 12 kilometers an hour, you still won't get the mark, because obviously you've not designed it to meet the specification required. 5.11 system interface, you have two choices for this. You can either use a voice system to give battery level and speed in 2-minute intervals, or you can use an augmented reality type system whereby there's a monocle or a heads-up display or something on goggles, or an LCD panel mounted from a helmet that is within view but not blocking view, to show the battery level and speed. So for either of those, whichever way you choose to do it, could you please firstly specify which one you are going for, because each of the two systems attracts slightly different marks. And can you provide a schematic diagram for that system? So your wiring diagram, it might be that you're using an Arduino Uno, in which case you can just use a block diagram for the Arduino Uno. If you're using the Arduino Uno to program the Atmega 328P chip, and then you're taking that out and putting it into a different circuit, you will need to show the whole circuit. But either way, you will also need to show how it's connected to the LCD panel, the type of LCD panel, any interfacing circuitry, and any cut of power. For example, the Uno runs nicely on 5 volts. It tends to fry on 12. So if you're using a 24 volt system, then obviously you're going to need some way of cutting the voltage down, and you need to show how that's done as well. So we need a schematic diagram for the system, and also please provide the program you're using and the programming method. So you might be using Arduino IDE, you might be using a library for your LCD, in which case just specify the library, and then any other information regarding the program, as in a flowchart that you've developed or the actual program itself, please add that in. Any programming method is valid. You're not going to lose marks for using any programming method out there. Totally your choice, whatever you're comfortable with, whatever you have a knowledge of, but please specify it. So 5.13, flashing lights. So the system actually requires flashing lights on the front and back. 2 small LEDs that can't be seen by other road or pedestrian users in the area is no good. So we need a nice flashing light system that actually shows to local people in the vicinity of your vehicle, that the vehicle is active and moving. You can be any colours you like. There's nothing that says it has to be amber or green or red or whatever. Any colour you like, a selection of colours, don't mind. But in order to prove that that's there, what I would need from you again is the mounting position of the flashing lights, highlighted from your CAD drawings, shown these holes are where it goes, or this is a picture of the lights actually attached. And from that, you need also to provide the circuit schematic that does that. So you might have bought flashing LEDs and there may not be much of a schematic, in which case please say so, but it will still somewhere connect to a battery via the switch system to say when it's going or not. You may have a an A-stable multivibrator running it, in which case I'd like to see the schematic for the A-stable that you're using, and again how it connects through the switches to the power supply, etc. 5.14, onboard charging system. Now there are 2 charging systems required, one to charge the battery for the personal transport vehicle. Don't want to be removing batteries to charge it when we sell it to the public. And the second one is a USB point to charge phones or other similar devices. So in order to prove that that's there for me, I need you to give me the schematic and drawings showing the mounting position and the connections for the charging system and circuitry. As I said in the full briefing, I would prefer if you used a charger that was already down to 19 volts or 24 volts or below, really. Absolute maximum cut down of 50 volts, something similar to what plugs into your laptop perhaps, or your phone, that kind of thing. And actually cut the voltage before it goes into the personal transport system. I don't really want 240 volt connections. That's not safe under the circumstances we're working, without lots and lots of quality checks, which in the competition you won't have time for. So if you could just represent the transformer box that you're using as a block diagram, but then show the regulation circuitry and overload and charge circuitry that you're using for the charging of the battery, and for the USB system, any regulation that you have to cut your battery voltage down to the USB 3.3 volts. So 5.15 battery system, your schematic has simply got to show that there is a battery there and what the value of that battery is, and also one of your CAD drawings showing where the battery is fitted, and that's it, you have that mark. That's a really, really easy one, and I wish I could spell please. Distance covered. So you've worked out the speed that your vehicle will do, yeah, so you can use that calculation now to work out how long it will take you to cover 3 kilometers, and how much battery power you will use for 30 minutes is a separate calculation. You need to add the two together, so your 3 kilometer distance run might take 20 minutes, which means you need an extra 30 minutes to that, total of 50 minutes run time at least. You might find that you can only cover 3 kilometers in an hour, in which case it would need to be an hour and 30 minutes. You might be able to do 3 kilometers in 10 minutes, so in which case it would need to run to 40 minutes. So it's going to be individual to your particular design and the speed of that design, and of course calculating for the weight and motor torque and all those other things. You've got to take a few of those into account, but ballpark figures is fine for that. Okay, so I've now discovered that I'm going to run for 50 minutes, and I know the rating of the motor or motors and how much current they're going to draw at that speed, so I can then work out exactly how much battery charge I'm going to need to do it, and then you design in your battery to do that. So if you can prove that the battery is big enough to cover for 30 minutes runtime plus 3 kilometers, so a few simple little calculations there, the marks for this are given as well. The packed volume of the personal transport system then. So on the actual national competition, we're going to ask you to put it into the rucksack, and we're going to measure it from its maximum extremities, so maximum length, maximum width, maximum height, and we're going to calculate the volume from that. So again, I'm going to ask you to do exactly the same here. So once you've done your CAD assembly, can you do an assembly of it packed as it should be with all parts on it? And on the assembly, the maximum extremities need to have measurements put on them. So if you create a drawing of that assembly with X, Y and Z planes clearly measured, that would be absolutely fabulous. That shows it brilliantly. You can use the X, Y and Z measurements to then calculate the volume of the project. What we then do is I'm going to put that into a spreadsheet and compare everybody's, and basically the team with the smallest volume will get the high marks, the team with the largest volume will get 0 marks, and everybody else will be graded proportionally in between. So there's a little bit of a problem with this one. From your point of view, you don't know how big or small everybody else is making it. So you might think, right, I've made the most fabulously wonderful push bike that folds into the tiniest space, it's barely bigger than a wheel, and somebody else comes up with a design that's half the size. You just don't know. So from that point of view, you need to really consider how you're going to do the project and what's the smallest area you can get it into. But bear in mind, a small vehicle might have more trouble going over the sand and gravel in the final than a large vehicle like an e-bike would. So it's a kind of a trade-off. Okay, costings then. So for Portfolio A, you are required to give a Gantt chart in, and that's part of the Portfolio A, and Portfolio A and Portfolio B remain pretty much identical to the national finals. So for Portfolio A, you've already created your Gantt chart, so you can use that Gantt chart to work out the total amount of time. Now bear in mind you have from 8:30 in the morning till 5 p.m. Thursday and Friday, plus a lunch taken out of that. You might only take 30 minutes for lunch, you might take an hour, and any other breaks. So in total you've got somewhere around about 16 hours. You may have a bit of tinker time on the Saturday morning depending on where we go and if it's needed, of course. So working on that, 16 hours roughly, a little bit more maybe, a little bit less maybe, depending on how many breaks and length of lunch, etc. So you might take the full 16 hours, and to be fair, most teams will get close to that. However, you might only need to take half of that. You might think you can do it all on one day and only take 8 hours. That's great. As long as your Gantt chart provides enough evidence that your main project and everything else can be done in that time, I'm happy to take your estimate. Now, you will also be able to calculate the time taken on machinery from that, so you'll know how long a piece should take your machinist on a lathe. You'll know how long your welder needs in a welding booth. And I am aware that these are just estimates, because until you actually start to build it, you really don't know. But try and make them genuine estimates. And for the surprise project, in each at the national finals, they're designed to be around about 3-hour tasks. So the machinist will have around 3 hours on the lathe. The welder and fabricator will have 3 hours welding and fabricating, and the electronics person will have around about a 3-hour build on that. You might be really, really good, and you might be only needing 2. You might be really, really slow, and you might be needing 4. But for the purposes of the qualifier, we'll just take it as 3 hours for each team. So you need to factor that into your Gantt chart and factor it into your total working time and your machinery usage time. So you may not use the lathe at all for your project, but you would still need to put 3 hours down for the lathe in order to show the 3 hours for the surprise project. So the first one is 6.61, working hours. Using the Gantt chart, come up with the total team working hours, log that down and provide the total working hours on a log. So I'm just looking for either a spreadsheet or a simple written sheet that says 6.61 working hours, our team estimate is. Along with that, upload your Gantt chart into this section so I can simply refer to it and check that you've got it right, and that will be sufficient evidence for your working hours. 6.62, cost of additional equipment. So the equipment that you have is a lathe, a welding booth, pillar drill, guillotine, cut-off or bandsaw. It will be one or the other, and the box and pan. So for those items you need to put down how many hours for each one, or how many 15-minute slots is the absolute minimum. You will need to do it. So you can't put down 2 hours and 25 minutes, but you can put down 2 hours and 30 or 2 hours and 15. Those are the times. But don't forget that 3 hours in the welding bay, or 3 hours combined between the welding and the fabrication equipment, and 3 hours on the lathe is going to be shown there, because those are the surprise project elements. So you use the Gantt chart again to estimate this, and the Gantt chart's already been uploaded with 6.61, so it's all in the same category. Great, it's there as evidence of both. And then provide the total usage hours for each piece of equipment. From there I'll calculate a cost, and we will compare who is the most and least expensive on the machinery use. The final part is raw materials. Now, there is a spreadsheet on the Google Classroom, and I will have emailed it you as well by the time you're watching this, and that spreadsheet needs to be completed. There is instructions in the qualifier on how to use that spreadsheet. Sorry, not in the qualifier. There is instructions in the national briefing on how to use that, and a little quick demonstration on the spreadsheet. So please use it, and please use it correctly. It's less important to get it wrong, to get it right in the qualifier, because I can give you feedback and tell you that you got it wrong. But in the national final, if you get it wrong, you will lose marks hand over fist. So complete the spreadsheet using the template, make sure it's there, list all the raw materials and all purchased items along with the cost as appropriate. So raw materials, metals, batteries, PCB substrate, plastics, that kind of stuff, all have a fixed cost per weight. You can get the weight from the CAD drawings, as we've seen a little bit ago, and you can calculate it that way, and that works out your raw materials. But then for purchased equipment such as nuts, bolts, resistors, capacitors, LEDs, all of that, there are two sections, mechanical and electrical, and they need to have, this is the item, this is the drawing number it goes to, this is the description for the item, this is how many I'm using, I bought them priced per piece or per packet or per length, and then the cost in GBP, that will convert into euros. You might have bought it in yen, so it could be cost in yen, as well, or any other country for that matter. There is a conversion ratio set on the front sheet of that spreadsheet for you to give you set conversion rates that are a snapshot of about 2 years ago, I think they are. And that will convert it all into euros, and then we have a total price for all of your materials in euros. Those raw materials will then go cheapest, will win maximum marks, and then we'll have 10% categories over the cheapest. So it'll be 110%, 120, 130. But when we get to 200%, if you are 200% above the cheapest, you will score 0, and so will everybody else. So if we had 5 or 6 people who were in the range of 450 to 650, but one team came in at just 230, that would be the only team that scored. If we have a team, all teams coming in within the 200 to 400 euros range, brilliant, all teams will score something. So it works a little bit differently to the others, but it is an important category to try and get right. So then we move on to Portfolio A. There are minor differences from the national final requirements, and for more information on how to do Portfolio A in detail, please do look at the briefing for National Final. That will take you through Portfolio A. But for the National Final, you're required to use real world videos, real world pictures. So in your brief, in your operation manual, I would expect to see real pictures of a real product. In the video section, I would expect to see real videos of a real product, and in the leaflets that you're to provide, the sales brochures, I would expect real pictures. That's not going to happen for the qualifier. You won't have time to do it, I very much doubt. If you do, great, please be my guest and put them in. But if you don't worry about it. I am quite happy with rendered 3D images for the qualifier. So some of the other things that are there, instead of videos, you can use animations that you've created on CAD. Inventor presentation mode is a pretty good way of doing it, but you may or may not be particularly au fait with that, and you might have a different way of doing it, and I am open to accepting any type of animation, however you would like to do it. So Portfolio B, that remains exactly the same as the November final, and there is a video called WorldSkills UK Live MTC Portfolio B support video that you can find on YouTube. The link for that is on the Google Classroom, and I will have emailed it to you also. Please study that video. Please try and follow what's on there, and please try and produce the videos to that standard. And as I've said, at the end, I need you to upload those videos as PDF files by exporting them to PDF and sending me the PDF. I may not be able to open the version of CAD files if you send them through as the raw IPTs. So please don't do that. Okay? So, in summary, this might seem like an extra or different work, but actually it's not if you're doing the design process fully and properly to get to the point where you have a prototype. You should have done all of these things. The best way of finding out how fast something is to try and work it out when you order the motors and the gears and the wheels, not to buy it, try it, and then buy some more, because invariably you will. That ups your development costs and takes time for the things to be delivered. So normally I would say, right, I want to use a 110mm wheel, I want it to go 5 miles an hour. What's the rotation rate of that wheel? This is the motor I have, these are the gearing ratios then that I need in between. Or you might have direct drive and you might just go, right, I need 1200 RPM and I can actually buy a 1270 RPM motor. That's me sorted. That's great. Whichever way you do it, it is not extra work, it is just the work you should be doing anyway. So you are asked to do simple calculations on the prototype design, the simple calculations that are needed. You may need to make changes though once you've built the item in reality. So I'm not expecting you to have a design at the qualifier and come with exactly the same design to the national finals. In fact, I'm more expecting it to be altered, changed, improved when you've actually built the prototype and found something doesn't work quite the way you thought it would. So Portfolio A may need subtle changes also. There's going to be changes such as Portfolio A asked for real world pictures, which you won't have for the qualifier, and as we've discussed, you can put CAD pictures in. The video has asked for real world footage in the national final, whereas quite happy in the qualifier for you to use animations. If you're absolutely desperate, you could use stills, but they won't be marked the same. So when you use when you get there, you will have a reasonable template for your Portfolio A. You'll be told by me what may or may not need improving, what you've missed, what you haven't missed, that kind of thing on feedback after the qualifier. So you should be able to then make those changes to maximize your marks in Portfolio A. And Portfolio B is exactly the same. That's a chance for you to get feedback. If you've missed something on the WorldSkills standard, I will quite happily tell you, and you will lose marks accordingly in the qualifier, but that's okay so long as you get through, because other teams might do better. Then you will get some feedback that says, okay, you missed quantity off, you missed your general tolerance off, that kind of thing, and then you can go back and improve your actual portfolio. And though social distancing has necessitated this change to the format, principally, we are still looking at what's going to be going on at WorldSkills Live. There might be a change in format, there might be less public allowed into view, there might not be any public allowed into view, although I very much doubt that would be the case. There are a few things that we're looking at that may or may not happen depending on the circumstances with lockdown and also the circumstances and guidance given to us by the government at the time. But in some format, some way, this competition will be going ahead. We will be awarding medals, and of course this year is not a selection year for an international squad. Next year is the international squad selection, so it's still a very, very good training ground for those who think, right, I'm going to come back next year stronger, better, learn from this experience, work out what it is I need to do, because I want to get into squad and I want to represent the UK in Lyon in 2023. So for those people, this is still going to be a very good training, and to be honest, having to move to an IT-based system, that's meant I've given you a lot more support than I maybe would in previous years. Getting through to squad is when the support from me normally occurs, but you're getting quite a lot of it now, so you should be in a very good place to do that. So the more you attempt in this qualifier, the higher your score should be. The higher your score should be, the higher the probability that you will be invited to attend the national final. However, if you miss bits out, hold your breath. You may or may not. Other teams might miss things out, might not be able to do something, might leave it till last minute and fall flat trying to get it rushed in, and that's normal enough for some. But for the good teams, those who really want to succeed, do this early, do it quick, do everything. And if you have any problems, and that's for everybody, come back to me, ask me, check with me. I am more than accessible via email. So note the scores for the sections in the qualifier. These have been changed slightly from what they are in the national final. Obviously, I've increased the marks on a lot of them in order to compensate for the fact that we are not doing all 21 elements in Section A, for example. We're not doing the surprise projects, and there are subtle changes to Portfolio A and B, but those marks remain the same for those two. For the rest of them, there has been changes to the marks. So please, when you get through to the nationals, remember that the marks for the qualifier were different. Other than that, I would hope that I get some good work and some questions and speak to you all on Google Hangouts shortly. And let's get cracking on a ruddy good final and make the best of the situation we're in, please. Ta-da for now.